So we have a nice geometry problem, but before we dive into this problem, so I'll just remind something about the surface area of a cylinder. So let's remember that like when you have a cylinder, so let's say we have a cylinder right here, and what I will do, I'll try to kind of visualize the finding the surface area of the cylinder, right? So like if you were to like us to find the surface area of this like cylinder. So we have, the circle at the top and the circle at the bottom, but there is a curved region which is not like easier to see. So for that reason, like we usually find the net of this figure. So when you, let's say, cut it from one like vertical line and then extend it. So when you do so, you will actually get something like this. Okay, so if you don't really see this immediately, so it's good to kind of take some time to digest this part, and then we are gonna get a like circle, the top circle right here, and another circle right here, because it's harder to find the surface area with this figure, but it's kind of easier to do with this figure. But if you really cut it through this line and then open it, and then you will actually see there's the rectangle. If you don't believe it, so you can just make a like paper and then actually convince yourself. So these are the same thing when you open it. So then if I want to find the surface area of this cylinder, so this is R, and then let's say this is H. We want to find the surface area of a cylinder. So we have two circles, like which is this one. This has a radius of R, and then this is also has a radius of R. And the area of the circle was the pi times radius square. But we have two copies, the top and bottom, so we multiply this by 2. And then to find the area of this rectangle, this side of the rectangle is the same as height of the cylinder, which is h. But the other side, which is a bit challenging to see at first, is like this one, this distance. Like, when you unfold this, you actually get the circumference of this circle. Again, if you don't see this, please pause and maybe use a paper and then make that cylinder and unfold it to see this circumference is actually the same as this side of the rectangle. The circumference of the circle was 2 pi times radius, which means this side of the rectangle is also 2 pi r. So now if you want to find the area of the lateral area, I would say, of this cylinder, which is the rectangle in this case, is going to be 2 pi r times h, because if you multiply this side by this side, you get the area of this rectangle, which is going to be lateral area. So this piece is called lateral area. And then this is the area of the two circles. When you combine the lateral area with the two circles, you actually get the surface area, which is the sum of these two. So I hope that was clear. So now let's look at our question that we are given. So the question says the company makes a cubic part with the cylindrical hole through it. So there's a hole inside. And then later we are gonna coat it with this sealant that is 0.1 centimeter thickness. And the cost for each sealant is gonna be $1.5 per cubic centimeters. Okay. And like, it's a bit challenging to understand, to be honest. Like it says the first part, find the surface area of the part. Like the part is just the figure that we see, right? But if you didn't really have this hole in it, we have a cubic figure. So, and then we can just find the area of one face. Maybe, I don't know, let's say, I'm gonna take the, like one face. Let's think about this face. So if I want to find the area of this face, which is the 10 by 10, which is 10 square, right? But we have 6 of these, right? So we have 6 of like the cubic sides. So if you multiply this 100 by 6, you get the surface area of the cube when there is no hole. But now we have a hole, so which is why we have to include some additional the surfaces that we have, which is when you have this hole, there's a like curved region inside. So I hope that's easier to see. So we want to find the lateral area basically, which is we are going to use this guy. So that will be plus because you are making another like outside figure because there is a like hole inside. So that will be the circumference of the circle 2 pi times r. So since this is the diameter, so I will say the radius is just 3. So you multiply this by 3. This is the circumference of the circle. And then when you multiply this by height, which is going to be like this distance, that's the same as 10. So which is why the height of that lateral like face is going to be 10. So 2 pi r the circumference, and then 10 is the height. So we just use this lateral area to find the lateral surface area. But since we kind of have a hole right here, so we make actually a circle that has no surface area. But when we do this 6 times 10 times 10, we include the front face, including this part as well, but there's a hole, so we have to subtract that region, which is a circle. So we just subtract the area of the circle. Pi times radius squared is area of a circle. But we have 2 copies. We have 1 copy in front and then at the end. So we multiply this by 2. So this is the area that we have to subtract from our sum. So if you combine these, like that will be the 600. And then that will be 6 times 10, 60 pi. And then that will be 9 times 2 is 18. 60 minus 18 is 42 pi. And if you want to leave it as exact answer, you can leave it that way. But if you need in decimal, so this is going to be approximately 700, like 31.95. And then since we have the unit as a centimeter, so that should be centimeters squared since that's the 2D. So that's the part A. So, and then part B is the volume is the product of the surface area and its thickness, right? So, and then we want to know the volume of the cylinder that it will be used to cover the part, so which means the whole figure. So we already know this is the surface area, and then we are given the volume as the product of the surface area and its thickness. So the surface area is this number, so we already know that. So then this volume will be approximately 731.95 times the thickness will be 0.1. So if I multiply these, so I will get the volume of the part, which is going to be 73.2 if I round it to the nearest 10. Because if you multiply this by like 1 over 10, you will get 73.195, which is approximately 0.2. So that's the volume. And the last part, how much does it cost to seal one part? So, you know, this is the volume of one part. And then we are told sealing costs $1.5 per cubic centimeter. So this is actually centimeter cube. Okay. And the last part, we could say just the cost is equal to the volume times the 1.5, because this is the total volume, and then each per cubic centimeter it costs this much. So I will say 1.5 times 73.2 is going to be like approximately 109.8. So I hope that was clear. So make sure you really understand this part instead of just memorizing this equation for the surface area. And I highly recommend you to either use a like paper and then apply this and then really see that's the case, or you can just look at some videos about opening these nets as well to make sure you actually see why this is the case. Okay, so I hope that was clear. I'll see you in the next video.